Hey guys, it's your pal Dave from notesandvolts.com, back with a new project. So you may know me as an electronics guy, but what you may not know is I do music as well. I stream music on Twitch, and I also have a new YouTube channel called Synthwave Dave, where I play all the synths and the guitars and do the live performances and all that fun stuff. It would be so great if you could check it out and give it a sub. Thank you so much. So while I'm doing my live performances, I like to have some flashing lights in the background to add a little interest. Now, when you deal with music gear, of course we use Midi to connect everything together, but when you deal with lighting gear, you have to use something called DMX. So you can think of DMX as basically Midi for lighting. That's how you control things. And you can see I've got a couple of DMX lighting fixtures above and below the TV. So to control my DMX lighting, I use a program called Sound Switch. Now Sound Switch does a couple of really cool things. First of all, it controls DMX lights. It also allows you to sync things together using Ableton Link. So if you're using Ableton or anything that synchronizes with Ableton Link, you can synchronize the timing of your lights to your music software. It also controls Philips Hue lighting. So I've got a lot of Philips Hue bulbs around the lab, and it will control those as well, just like a DMX lighting fixture. Very cool. So to capture the audio and video for my live streams, like most streamers, I use a program called OBS Studio. And that's what I'm actually using to record this intro. So the other day I thought, wouldn't it be cool if I could use my lighting setup to control some video effects in OBS? Unfortunately, I couldn't find any way to get DMX signals into OBS, but I did find a plugin that allows you to control it with Midi. So all I needed to do was to create a project that would take DMX signals in and convert them to Midi signals that OBS could understand. And after a lot of trial and error, I came up with a project that I'm calling the DMX2 Midi. So in this video, we're going to look at the code and the schematic, and I'm going to explain how it all works, so hopefully you can build one yourself. But before we jump in, let's take a second and give a warm thank you to the sponsor of this video, PCBWay. PCBWay is a one-stop solution for all your circuit board and manufacturing needs. They can do circuit boards, multi-layer boards, aluminum boards, 3D printing, CNC machining, injection molding, and assembly. They can do it all. PCBWay is very maker-friendly with lots of services for small creators like myself. So check out PCBWay today and they can make your dream project a reality. Click the link in the video description to let them know that Dave sent you, and you'll get yourself some free goodies. So thanks again to PCBWay. So let's take a quick look at what this project can do. So first of all, we'll start a drum beat. Give us our tempo. Now you can see I've got my hue lighting in time with the beat. Now we've added our DMX lighting fixtures, all working together, all keeping time. Now here's where the fun begins. Let's send a DMX signal to OBS and change the zoom of my video window. And there you go, we've got some crazy effects going on. That's kind of cool. Now let's add a video filter that's going to flash on and off to the beat. Oh man, this is getting crazy. Hey, wait a minute, there's one more channel. What does this one do? Oh my God! Okay, let's take a look at the hardware. So the first thing we need to do is take a look at the circuit. So here's the schematic, and here is the actual circuit on my vintage Radio Shack breadboard. Very cool, but any breadboard will do. You don't need this vintage one. I also have a vintage Darth Vader PED dispenser, but that has nothing to do with this project, so you really don't need this, but it's great to have. So let's talk about the components in the circuit. So the heart of this circuit is this teensy LC microcontroller. And here it is on the schematic. I love using the teensy boards because they're just such a joy to work with, and they handle USB MIDI so well. So you could use the Teensy LC, you could use the Teensy 3 or a Teensy 4. But if you need to do this with Arduino, the code won't work as written as it was written specifically for the Teensy boards. So first of all, let's talk about the power supplies and how power is getting to our circuit. So you can see right here, we've got our USB cable coming in, and that is powering the Teensy and also transferring the data to our computer. The USB cable is going to give us 5 volts, and that's going to power our Teensy. Now, the 5 volts from the USB is also available at this pin here, the V-in pin, or as it's labeled on the board, the 5V pin. So that's going to give us our direct USB power out. Now, one thing to keep in mind, the Teensy LC is a 3.3 volt device. It will not tolerate 5 volts. You cannot put 5 volt signals into it. So keep that in mind for the rest of this explanation. So even though we've got 5 volts coming into the Teensy from our USB, the Teensy has a built-in regulator that's going to cut that voltage down to 3.3 volts, and that's what's going to run the processor on the board. That 3.3 volt regulated power will be available at this pin right here, and we can take that voltage out and power any 3.3 volt devices on our board. We also have ground pins here and here. They're both connected together, so you can use either one or both. Now let's talk about the DMX signal and how to deal with that. So DMX is based on a protocol called RS-485. And RS-485 is designed to transmit a signal over long cable runs. Now that is great because if you think about the average stage setup, the lighting guy is probably at the back of the room and the stage has got all the lights, so he has to run a cable all the way there, and there's people jumping all over the place and rock and roll guys with their electric guitars causing all sorts of interference. So there's a lot of chance for that signal to get messed up. But the RS-485 protocol kind of keeps that signal clean, so it makes it all the way to the stage and you can enjoy your rock and roll performance. So to make that signal robust, the DMX controller actually sends out 2 signals. One is the mirror opposite of the other. So if one goes up to 6 volts, the other goes to -6 volts. And then your DMX receiver kind of combines them together and makes one solid signal out of them. But none of that's going to work with our little teensy microcontroller. It wouldn't even know what to do with it. It would just blow up. So to handle those messy DMX signals, we're going to use this little guy here. Now this is called a MAX485 to TTL module. The MAX485 chip has one job, and that is to take those messy RS-485 signals and turn them into a lovely and polite 0 to 5 volts TTL output. Now these modules I found on Amazon contain the chip and a bunch of support components, and they're very cheap. So I thought instead of trying to rebuild this whole circuit, why not just get a bunch of these and just call it a day. Okay, so now let's take a look at the circuit from the input to the output. So at the start of our circuit, we've got these 2 XLR type jacks. Now DMX can either use these 3-pin jacks, or it also comes in a 5-pin version. And you can use either one with this circuit. If you use the 5-pin jacks, just make sure you look up the pin numbers and wire them accordingly. So we'll attach the cable from our DMX controller into this jack here, and that's going to go to the input section of our MAX485 module. So if you take a look at the input section here, there are 4 pins. There's a VCC, a B, and an A, and a ground. Now, first of all, we need to provide power to this chip. So you can see our VCC is 5 volts and our ground is ground. So to get our 5 volts, we're going to take it right from the Teensy's 5 volt pin. And you can see I've run a wire from that pin all the way under here and into this pin here. Now, one thing about these modules, they're kind of a pain in the butt to work with because they don't really fit in a breadboard, and they've got these pins pre-soldered. So what I did is I got a bunch of these male to female headers so I can just kind of put them on the pins and plug the other end into the board. That's how I worked with it. And to make it fit, I just kind of stuck it on the board so half of it's hanging off. It's kind of a mess, but it works. It's okay. So we've got our 5 volts going to our module. Our ground is going to go to any ground from our Teensy. So what I did is I ran the ground pins, one up to this strip here and the other one to the blue strip at the bottom. So both of these strips are now grounded. So now that we've powered up our chip with 5 volts and ground, I have to connect the 2 data lines to the B and A inputs. So if you look at our diagram here, pin 3, which is the bottom pin, is going to go into the A input, and pin 2 is going to go into B. So we got pin 1 is ground, so that's going to go to the ground on our Teensy board, which is our system ground. So a lot of times when you're running DMX lighting, you're going to have your input in here and then an output jack that's going to continue the signal along so you can run it to your other lights. So that's what we've done here, and all we've done is wired the jacks in parallel. So pin 2 on the input goes to pin 2 on the output, and pin 1 and pin 1, and so on. So just kind of wire the jacks together, and you'll get your input mirrored on the output. Now, to make these jacks a little easier to work with while I'm breadboarding, I once again got these male to female cables, and I cut the male end off and then basically soldered it to the jack. So now I've got this and I can plug it into various things. So now we have power and data going into our little converter board here. It's going to do its conversion and it's going to spit out 0 to 5 volt TTL logic signals out the other end. Now, if you look on the other side of this board, there are 4 pins. There is DI, DE, RE, and RO. So what does that stand for? So the DI is the driver pin, and you can think of that as the transmitter pin. That's going to send signals out. Now, since we're only receiving signals with this circuit, we're not going to use that pin. Now, the RO pin is the receiver pin, and that's going to take the signals we get from here and output them into our Teensy board. The 2 other pins, the DE and RE, are driver enable and receiver enable. Now, if you look here, both of those pins are connected to ground. We do that because we want to disable the transmitter pin and we want to enable the receiver pin. And if you notice, the receiver pin has this little line over it. That means that that pin is enabled when you put a low level signal or a ground signal into it. So the transmitter pin is disabled when you put ground into it. And that's kind of convenient because we only need one signal to disable one pin and enable the other. If we flip this to plus 5 volts, we would then enable the transmitter and disable the receiver. So we're going to connect both those pins to ground, and that basically just enables our receiver pin. So now we've got our messy DMX signal turned into a nice 0 and 5 volt logic level. Now remember, we said our Teensy board can't accept 5 volts, so we're going to have to condition that signal to get it in there safely. So that is what this chip is going to do, and here it is on the board. This is called the 74AHCT125 chip, and this chip is called a quad buffer chip. And what it normally does is take a low 3.3 volt signal and drive it up to 5 volts to run 5 volt logic. But we needed to do the opposite, which is to take our 5 volt signal and cut it down to a 3.3 volt signal. So to do that, we're going to power it with 3.3 volts that we can take from the 3.3 volt pin on our Teensy. So there's our 3.3 volt pin. I actually ran it to this red strip, and there you can see it going into pin 14 of our chip. We also need to give it a ground, and that is on pin 7. So there it is right there, going to the ground strip to our Teensy's ground. Remember, when you count the pins on these chips, you'll find a notch on one end, and the pin directly to the left of that notch is pin 1. And then you go counterclockwise around the chip. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So like I said, this is a quad buffer, so that means there's 4 different buffers in one chip. So we're just going to pick one. I chose buffer number 4 for this example. Now these buffers have 3 pins. So it has an enable pin, and this is ground enable, so we have to tie the enable pin for the buffer we want to ground. So that's where I've got this going to the ground strip. Our buffer 4 has 2 pins, an A pin and a Y pin. I don't know why they're called that, but that's what they're called. The A pin is going to be your input. So we're going to take the output from our driver board, which is 5 volts, and that's going to go into the A pin on our buffer. Now the Y pin is the output, and there it is right there, and I can take that and run it up to input 0 on my Teensy. So there's the wire running to input 0. So remember, we've got 5 volts coming into this chip and 3.3 volts coming out into the Teensy, which is going to keep our Teensy safe. So there's only one more part of this circuit, which is our little indicator LED. So I'm taking a wire from output 16 on the Teensy into the LED, and then through a current limiting resistor, which is 220 ohms, into ground. And that's going to allow this LED to light up when this pin becomes active. So notice there's also a built-in LED on the Teensy, and that's going to give the same information as our indicator LED. So if you don't want to include these two components, you can leave them out. But I figured if you're going to put this in a box, it'll be nice to put that LED sticking out so you can actually see that it's powered on and that it's working. So one last thing about these modules. So like I said, these put out 5.5 volts. And that's why we need our little buffer chip to make it work with our Teensy. Now you can find these in 3.3 volt versions. And if you found one, then you could potentially do away with that chip. But I found them hard to get, and I could find these 5 volt versions all over the place, and they were very cheap. So that's why I went with the 5 volts and the converter chip. But if you can find a 3.3 volt version, then it may be easier. All right, that is how the circuit works. All right, we've seen the hardware. Now let's take a look at the software. So first of all, you'll need to download the software. So go to the link in the bottom of the video and you'll find your way to my GitHub page. You'll find my DMX to Midi project and go to releases and click on that. And under releases, you'll find a couple of options, either the zip file, which you probably want, or the tar file if you're so inclined. Just click on the one you want and you'll get that downloaded to your computer. Once you have it downloaded, unzip it, go into the folders and find the dmx2midi.eno file and open that up. So this is the dmx2midi.eno file, and it will open up in your Arduino software. You should have two tabs at the top, name.c and dmx2midi. Before we upload, we need to set a few parameters to get it ready for our Teensy LC. So if you go to Tools and you go to Board, you should get the Teensy Arduino menu. If you don't have that, you have to go to the Teensy website and download the Teensy Arduino software, and then you will get these options. So select Teensy Arduino and select Teensy LC. USB type, make sure it's at MIDI. All these you can leave as they are. Next, go to port, and once you plug your Teensy in, it should show up as a selectable device. Make sure it's checked. And there we go. Just for your reference, here are the upload settings that we just set. To compile this program, you're going to need one library. This is called the Teensy DMX library. To check if you have it, go to Sketch, go to Include Library, scroll all the way down, and you should find it right here. If you don't have it, you need to install it. So go back to the top. Go to Manage Libraries. Once your library manager pops up, do a search for Teensy DMX. And after a minute, it should find it. So here it is, Teensy DMX by Sean Silverman, version 4.2. Just select the latest version and click Install. So now we're all set to upload the code to our Teensy. So let's take a look at the program and the things you can set. First of all, this is a very important setting, the number of fixtures. So right now we're using 3 fixtures. So in lighting terms, a fixture is one light. So that light up there is a fixture. So the way the program works, it treats each parameter in OBS as a separate fixture. So it kind of treats it like a light. So right now we're using 3 fixtures for this example, but you can set more or less depending on how many you need. The next thing we're going to look at is this debug variable. So once you're finished experimenting and setting up your fixtures, you probably want to set this to false because it adds some extra output and it might just slow things down. But for now, since I want to show you how this program works, we're going to set it to true. So we've defined 3 fixtures. Let's see how we set those up. So if you go down here, it says define fixtures here. And this is a fixture. Each one of these bracketed sets of numbers is one fixture. Now, if you look up here, this is telling you what each parameter means. So the first number is the DMX channel. So DMX basically has a channel range of 1 to 512. So you can set this to any channel from 1 to 512. Right now we have our 3 fixtures on channel 1, 2, and 3. For this example, I want to change that. So I'm going to change these to 15, 16, and 17. So these are the channels that each fixture will listen to. The next parameter is the Midi channel, and Midi, we can use channels 1 to 16. Right now we're going to leave these all at 1, but you can choose any channel number from 1 to 16. The next number is the Midi CC or note number. So each of these fixtures can either operate as a Midi CC or a Midi note on and off. Midi has a maximum range of 0 to 127. So these values here can be 0 to 127, and that will be your CC value or your note value. The next parameter will tell your program if your fixture is acting like a Midi CC or a Midi note. And all you do is type it in. If you want a CC, type CC. If you want note, type note. Notice that all the values are separated with a comma. Finally, we have 2 optional settings at the end here, the Midi minimum value and the Midi maximum value. So if you go back, you notice this first fixture does not have that. So it's, like I said, it's optional. If you don't include it, it's basically going to give you the full range of Midi values from 0 to 127. You notice on this fixture, I actually define those 2 values. So the minimum is 63, the maximum is 70. So what that means is the values coming in from DMX will get scaled from 63 to 70. So you're just going to get a narrow range of Midi values coming out. And that can be useful in certain situations that we'll see later. Now, the other option you can do with this, if you set this to 0, that's the minimum value. The values will get capped at 70, so at your maximum value. So no matter what values come in, as soon as they hit 70, they will not go any higher. Now, on the other hand, if I set the maximum value to the maximum Midi value, which is 127, and I set the minimum value to something other than 0, it's going to cap the lower level of your Midi signals. So I'm going to set this to 63 for this example. So that means anything below 63 will be sent as 63, and then between 63 and 127 will get passed normally. Now this last fixture on DMX channel 17 is going to be treated as a note on and off. So there's no minimum and maximum values for notes, but basically this will be note number 20, and you can look that up. It may be like a C sharp or something, but set it to whatever note number you want right here, and this will be your Midi channel. So if you want to add more fixtures, just make sure there's a comma at the end of your last fixture, and then just come in here, type a curly bracket, and type your new fixture. So we could do like 18, channel 2, number 120, and it's a CC. End it with a curly bracket, and if it's the last fixture, you don't need the comma, but you could add one anyway if you like. And now the important part, since we added our extra fixture, we have to go back to the top and change our number of fixtures to 4. So this always has to match the number of fixtures defined. So now we've got everything defined and we've got debug to true. We can take a look at the serial output and see exactly what the program is doing. So now all that's left to do is upload the program. So once again, tools, make sure your Teensy LC, type Midi, and that your Teensy is recognized and checked. And then once you've done that, just hit upload. And once it's finished, your Teensy uploader program should pop up, and you should see done uploading in the bottom here. Hey, you know what? This project has a lot of parts, so we're gonna have to come back for part 2, but make sure you check it out because we're gonna talk about DMX, sound switch, hooking this project up to OBS and getting it all working. It's gonna be fun. Before we go, I'd like to give a special thanks to PCBWave for sponsoring this video, and also a really special shout out to my patrons on Patreon. Thanks guys for supporting me, and let's enjoy your names.